Hello, Professor Barin Kumar Ji.
Speaking. Yes, speaking.
Yes. Nimai Singh. Hello, Professor Barin Kumar Ji.
Speaking, sir. Speaking.
Oh, yes. Thank you.
How are you, sir?
I'm fine. I'm fine.
Okay. Nice.
Very happy to you.
After long time.
After a long time.
Okay. Hope the first will be all right.
Yes. So very nice. Thank you, sir. Thank you.
Okay, sir.
Oh, yes.
They can hear you, and this is the video. If you want, they can see you also.
Good morning to all the delegates present here, eminent speakers and participants present both in physical and virtual mode. On behalf of Department of Physics, Tripura University, I feel privileged to extend my warm welcome to all present here to be the part of 12th Biennial National Conference of Physics Academy of Northeast 2021. I wish to mention here that the sixth PANE conference was also conducted by Department of Physics, Tripura University in 2009. We feel privileged to conduct the second conference after a gap of 12 years. About PANE, the Physics Academy of Northeast is an organization of physics researchers, especially from Northeast India. The first meeting of PANE was inaugurated by late Professor G.C. Deka at the Indian Institute of Technology, Guwahati on April 6, 1998, organizing the regional conferences, theme-based short-term conferences, and networking among the researchers to promote Northeastern researchers are some of the main activities of Physics Academy of Northeast. Here we will be together for various fruitful interaction for coming 3 days. The conference platform will provide opportunities for the young researchers to actively engage in informative discussion in the research field. With this small introduction, I now request Professor Ganga Prasad Prasin, Honorable Vice Chancellor, Tripura University and Chief Guest of today's inaugural program, with the request to come on dais and take the respective chair. I now request Dr. Deepak Sharma, Registrar, Tripura University, to kindly occupy the chair on the dais. I now request Professor Badal Kumar Datta, Dean, Faculty of Science, Tripura University, to kindly occupy the chair. Thank you, sir. I now request Professor Debajyoti Bhattacharya, Senior Most Professor of Department of Physics, Tripura University, and Chairman, Local Organizing Committee of PANE, to kindly occupy the chair. I now request Professor Sujay Chattopadhyay, Head of Department of Physics, Tripura University, and Secretary, PANE 2021, to kindly take the respective chair. I now request Professor Syed Ashad Hussain, Convener, Local Organizing Committee, PANE, to kindly occupy the chair on that. Thank you, sir. I would glad to welcome Professor Kushal Kalita, General Secretary, Physics Academy of Northeast, and Professor N. Singh, President, Physics Academy of Northeast, who will be present with us during the program through online mode. I also welcome the 8 distinguished physicists who will be felicitated by the Organizing Committee of PANE 2021 and Physics Academy of Northeast. Welcome, sir.
I would be glad to request our students to welcome Professor Ganga Prasad Prasen, Honorable Vice Chancellor, Tripura University, and Chief Guest of today's inaugural program, by presenting bouquet to him as a token of respect. Thank you, sir. I now request our students to welcome Dr. Deepak Sharma, Registrar, Tripura University, by presenting a bouquet to him. I now request our students to welcome Professor Badal Kumar Datta, Dean, Faculty of Science, Tripura University, by presenting bouquet to him. I now request our students to welcome Professor Surya Chattopadhyay, Head of Department of Physics, Tripura University, and Secretary, PANE 2021, by presenting a bouquet. Now, I would request our students to welcome Professor Debajyoti Bhattacharya, Senior Most Professor of Department of Physics, Tripura University, and Chairman, Local Organizing Committee, PANE, by presenting a bouquet to him. I now request our students to present a bouquet to Professor Syed Ashad Hussain, Convener and the Local Organizing Committee, PANE 2021. Now Now, I would like to call Professor Debajyoti Bhattacharjee, Senior Most Professor of Department of Physics, Tripura University, and Chairman, Local Organizing Committee, Pune, to deliver his welcome address.
Honorable Vice Chancellor Sir of Tripura University, Professor G.P. Singh, the patron of this conference, our respected Registrar Sir, Dr. Deepak Sharma, the chief guest of this conference, our respected Dean of Science, Professor B.K. Datto, Dr. Kushal Kolita, General Secretary of PANI, and also from Department of Physics, Guwahati University, he is present in online mode, Professor N. Nimai Singh, Chairman, PANI, and also from Physics Department, Manipur University, present in online mode, Professor Surya Chattopadhyay, our head of the department and organizing secretary of the conference, Professor Sayyid Asad Hussain, convener of this conference, joint conveners of this conference and faculty members of the department, Dr. Anirban Guho and Dr. Rakun Das, who are also present here, all the faculty members of the departments of other departments of Tripura University who are present here or in online mode, also other distinguished faculty members and other participants of various universities and institutes who are present in online mode, the scholars and students of the department who are present here, all the officers and non-teaching staff of the university. First of all, I heartily welcome our Honorable Vice Chancellor, Sir, Professor G.P. Singh, to this conference. Despite his busy schedule, he manages his time and gives his valuable time to present here to grace this occasion. On behalf of the department, I welcome you, sir, to this august gathering. Okay. I also welcome our respected sir, Dr. Deepak, respected Registrar Sir, Dr. Deepak Sharma. Despite his busy schedule, he manages his time to remain present in this inaugural session of the PANI 2021 conference. I heartily welcome him, sir. Okay. Professor B.K. Datto, our respected Dean of Science, he is a man of botany. He is doing very good research in his field of entomology. He is also very cooperative and enthusiastic person. On behalf of the department, I welcome you, sir, to this inaugural session. I also welcome Dr. Kushal Kolita, Secretary of PANI. He is present in online mode. He continues his effort and helps us in various ways to make this conference a great success. I heartily welcome you, sir, to this conference. I also welcome Professor N. Nimai Singh, Chairman, PANI, and also from Department of Physics, Manipur University. He also helped us a lot to make this conference a grand success. Our head of the department, Professor Surya Chattopadhyay, he is a theoretical condensed matter physicist and doing very good research. I also welcome him to this inaugural session of the conference. I also welcome Professor S.A. Hussain, the convener of this PANI 2021 conference during the last 2 months. He continued his tremendous effort to make this conference a grand success. I also welcome the joint conveners of this conference and my two junior colleagues of the department, Dr. Anirban Guho and Dr. Rakun Das, to this conference. They did a lot of work to make this conference a grand success. Welcoming, sir. I heartily welcome all the faculty members of other departments of Tripura University who are present here or remain present in online mode. Welcoming, sir. On behalf of the Department of Physics, I heartily welcome all the distinguished faculty members and other participants of various universities and institutes who are present here in online mode. My sincere welcome to all the scholars and students of the department who are present here. They really did a very wonderful job to make this conference a grand success. And finally, I also welcome to all the officers and non-teaching staff of the university. Thank you all.
Thank you, sir, for your welcoming words. Now, I would like to invite Professor Syed Asad Hussain, convener, Local Organizing Committee, Pune, and he will highlight the key points of the conference.
Good morning, Honorable Professor Ganga Prasad Singh, Vice Chancellor of Tripura University, respected Dr. Deepak Sharma, Registrar of this university, Professor Badal Kumar Datta, Dean, Faculty of Science, Professor N. Nimai Singh, President, Physics Academy of Northeast, Professor Kushal Kolita, General Secretary, Physics Academy of Northeast, Professor Surya Chattopadhyay, HOD, Department of Physics, Professor Debajyoti Bhattacharjee, Senior Most Professor of this department, distinguished physicists who will be felicitated during this program, delegates from different parts of the country, my esteemed teaching and non-teaching colleagues, officer colleagues of this university, research scholars, my dear students. We all know that during the last years, we were going through a tough time due to this pandemic. However, even this pandemic, under this pandemic, we are able to organize this conference. I am very happy in this regard. Actually, this conference, it's a periodical one, biennial one. It was supposed to be organized by the Tezpur University in 2020, but somehow they couldn't do it, so we organized this year. So it's a matter of pleasure for my department and my university. I would also like to inform you that our department regularly organize different events time to time. Even during this pandemic, this year, 2021, we have organized 2 faculty development program, 3 webinars. And another program I would like to mention, we organize international conference periodically. And the 3rd version of the conference was organized in last 2020, where 350 participants were there, and including 28 from abroad. So it was a big event. About this program, due to this pandemic, we organized this program in hybrid mode. That is, participants from this university only, they will attend physically. And participants from outside the this university, they will join us through online, either Google Meet or YouTube link. And this hybrid program is possible mainly due to installation of this kind of facility by the initiative of our Honorable Vice Chancellor. So thank you very much, sir. And it is very helpful for us for the classes also during this pandemic. And almost all departments of this university has got one of these facilities. So this is very nice. In this program, there will be 9 technical sessions, including 3 poster sessions and 17 invited talk, including 2 from abroad, outside India, 1 keynote talk. And the keynote, and also we have 30 oral, 151 poster presentations, and 55 participants without paper. And I am very happy to share that the keynote address will be given by Professor Sabu Thomas. He is the Vice Chancellor of Mahatma Gandhi University, but the important thing is that he is the most cited scientist of this country this year. His H-index 118. His H-index is 118, and total citation is 67,529 till now. So he will be delivering the keynote address. Regarding the participants, since it is an online and hybrid, so what we will do, we will take feedback, attendance after each sessions, and 80% attendance is mandatory to have the certificate. So participants, you please take care of both physical as well as online. We will share the link through Google Meet and also YouTube chat box. So this is important. Regarding poster presentation, this was also challenging, because how you will showcase your poster. What we did, we requested all the poster presenters to submit video or PPT for their presentations. We uploaded all the video in the website, and it is more than 120 videos. All are in the website, and we requested all the participants, even outside participants, they can go through the video. They can note down if there is any query. There is a number, reference number. With this reference number, they will note down. During the program, every day there is a schedule for the oral, and we have given some presenters that you remain present during this time. The people who has query, they will put their query in the chat box. There will be chairman. Chairman will read out the query, and the person will answer. So we tried our best way to make the poster presentation effective and interactive. So this is regarding poster. Another important issue, we will felicitate 8 eminent physicists of Northeastern region for their contribution towards development of physics teaching and research in this area. We will also provide 10 Pane Young Researchers Award, 5 for oral, 5 for poster. And this awards is being sponsored by Bipin Pal Das Trust, Guwahati. And the full paper corresponding to the presentations will be published in 2 journals. One is from Elsevier, Materials to the Proceedings. Another is International Journal of Engineering, Research and Technology. All these are in UGC KL list after the peer review. And deadline and procedural submission will be disclosed in the website in due time. I believe that the PANE 2021 conference will provide opportunity for young researchers to actively engage in research discussions, information about current findings, funding opportunity, new research interests, research ethics, professional development, and also, Tripura is one of the most remotest state in this region. And I believe that this conference will give an opportunity to the young researchers of this region for collaboration, for collaborative research activity, not only in the researcher of Northeast, but also in India and abroad also. So it's a big opportunity. You please do capitalize it. I am thankful to my colleagues, scholars, students, staffs of the department, as well as to the university, who helped me a lot to make this conference a successful one. I wish a fruitful discussion during the coming 3 days. Thank you very much. Thank you all.
Thank you, sir, for the small introduction on Pioneer Conference activities. Now, I would request Professor Kushal Kalita, Department of Physics, Guwahati University, and General Secretary, Pioneer 2021, to share his few words with us, and he will deliver his lecture through online mode.
So, good morning, everyone. So, good morning. So, Honorable Vice Chancellor of Tripura University and Chief Guest of today's conference, Professor Ganga Prasad Prosen, Honorable President of Physics Academy of Northeast, Professor N. Nima Singh, who is in Guwahati University now, Executive President of PANE, Professor Anurup Gohaibura, so he will be joining very soon. Honorable Chairman Local of 12th Biennial National Conference in Tripura University, Professor D. Bhattasarji, respected keynote speaker of today's conference, Professor Sabu Thomas, Vice Chancellor of Mahatma Gandhi University, Kottayam, guest of honor and Dean Faculty of Science, Professor Badal Kumar Dattaji, special guest of today's conference, Registrar of Tripura University, Dr. Deepak Sharma, Head of Physics Department, Professor S. Satrapordai, convener of 12th Biennial National Conference, Professor S. Arshad Hussain, joint conveners, Dr. Anirban Guha and Dr. Ratan Das, other office bearers of PANE, dignitaries on the dais, invited speakers, distinguished physicists who will be felicitated today, participants, ladies and gentlemen. So at the outset, on behalf of Physics Academy of Northeast, I welcome you all to the 12th Biennial National Conference for 3 days in Tripura University. The Physics Academy of Northeast is one of the largest academic and prestigious organizations among northeastern states. Its history spans over only 12 years. As mentioned at the beginning, it was inaugurated by the well-known educationist and physicist by late Professor G. C. Deka at the Institute of Technology, Guwahati on 6 April 1998. And that meeting was chaired by Dr. D. M. Buragohai, the then director of the institute. The academy is a brain cell of a gathering of eminent physicists of Northeast India, initiated by Professor K. M. Pathak, the founder, Vice Chancellor of Tezpur University, and by many others. The aim of this academy is to promote physics research, physics education, wide dissemination of physics information, placement of physics graduates of Northeastern region, physics thoughts and physics temper. The academy has registered under the Societies Registration Act since the year 2002. Several leading universities and institutions of Northeast India are now institutional members of the academy. For instance, Dibrugarh University, Guwahati University, IIT Guwahati, Nagaland University, Tezpur University, Center of Plasma Physics and Institute of Plasma Research, Institute of Advanced Study and Technology, IISST, Manipur University, NERIS, and perhaps the Tripura University. Now, the academy has 450 life members scattered in different institutions of Northeast India. The main office and headquarters of the academy was initially located at IIT Guwahati, but later on, after the retirement of Professor Y.V.G. Murthy from IIT Guwahati, the executive body of PANE held on November 27, 1999, elected Professor Dilip Kumar Sudhuri of Guwahati University as the executive president of PANE and Professor Bayan Kumar Sharma of Guwahati University as the member of executive body. For operational ease, it was also decided to shift the office to the Department of Physics, Guwahati University. Later on, Professor N. Nimar Singh, Professor Buddhadev Bhattacharjee from Guwahati University at the time, and B. Bhattacharjee from Guwahati University, and Dr. Ranjita Deka from Pragatish College also joined as the executive committee member to strengthen the activity of PANE. Since then, the Guwahati University has become the head office of PANE. So some of the main activities of PANE, and also some are newly added this year. So those are to conduct the Foundation Day lecture 6th April every year. We also organize biennial conference in any states of Northeast India. Felicitation of distinguished and senior physicists of Northeast India is our priority. Publishing PANE newsletter and e-journals or print journals is also in our agenda. Organizing theme-based short-term conference, seminar or workshop is also included. Conduct of awareness program for wide dissemination of knowledge, physics knowledge is our priority. We also conduct outreach program for undergraduate students because undergraduate students are the backbone of physics economy of Northeast. Also, we encourage collaborating research work among the northeastern states. Also, write monograph or book by the life members of PANE, so we should also encourage. We should also help important talk or webinar by its members to focus their talents. With these objectives in mind and strong regional support behind, so PANE has regularly organizing its biennial series of conferences apart from various workshops and panel lectures at different institutions. The first of the conference series was held at IIT Guwahati on October 17, 1998. Then onwards, PANE conferences were held consecutively. For example, 2000, it was held in Cotton College. 2002, it was held in Tripura University. 2004, JC College, Silchar. 2007, it was held in Guwahati University. 2009, so first time it was held in Tripura University. Then 2010, it was in Manipur University. 2012, it was in Mizoram University. Then 2004, it was in Neris, Arunachal Pradesh. Then 2016, it was held in St. Anthony College, Shillong. 2018, it was held Assam University, Difu campus. And 12th National Conference this time is on again on 15 to 17 December 2021 in Tripura University. So this is the list of where that biennial conferences were held. So I took the charge as General Secretary of PANE on April 2021 amidst the COVID-19 pandemic. We arranged an executive committee meeting online and decided to hold the 12th Biennial National Conference in Tripura University. I thank the convener, Professor S. Arshad Hussain and DSC of the Physics Department, Tripura University, to quickly take up the initiative to hold this national conference. Now we have received overwhelming response, about 160 contributory papers, out of which around 40 papers is selected as oral and rest are selected as poster. We also have substantial number of invited lectures in the conference to meet the global and local importance. The research topics covered various areas of physics like condensed matter physics and material science, astrophysics and cosmology, atomic and molecular physics, nuclear and particle physics, and atmospheric physics and instrumentation. The conference is organized with financial support received from Tripura University, Physics Academy of Northeast, and Bipin Pal Das Memorial Oration. We are thankful to the Vice Chancellor of Tripura University and Dr. Alakananda Das, daughter of Bipin Pal Das, for their generosity. We would like to appreciate the untiring effort of all members of local organizing committee and the student volunteers, which made the conference a success. We owe special gratitude to Professor S. Arshad Hussain, the convener, and Professor D. Bhattacharjee, the chairman of the local conference, and his team. This year, both Guwahati University and Tripura University also co-hosted a UGC DAE CSR awareness program on 6th August 2021 in the auspices of PANE to encourage the young researchers and students to submit research projects in-house and using large-scale DAE facilities. Thanks to Professor Amlan Jepal, Director of UGC DAE CSR Indoor Center, and Dr. Abhijit Saha, Director of the same but from Calcutta Center. It needs to mention that one of the books is in process of publication in Planet platform, written by eminent physicists of Northeast and edited by Executive President Professor N. Nimai Singh. With the help of cooperation of the life members of PANE, I do hope more and more such innovative sustaining work would be doing for the PANE in the coming years. With these few words, I thank you all once again and hope the conference will be a grand success. So long live PANE. Thank you very much.
Now, I would request Professor N. Nimai Singh, Department of Physics, Manipur University, and Chairman, Physics Academy of Northeast, to deliver his speech in online mode.
Thank you very much for inviting me to speak a few words. First of all, I'm pleased to accept my best wishes and warm greetings to all the participants in the 12th Biennial National Conference of the Physics Academy of the Northeast PANE 2021 in online mode as well as offline modes. Please accept my warm regards. My kind respect to all the dignitaries in the dais, our respected Professor G.P. Prasad, Vice Chancellor of Tripura University, Chief Guest of today's function, our respected Professor Deepak Sharma, Registrar of Tripura University, and a special guest of today's function, respected Badal Kumar Datta, Dean Faculty of Science, guest of honors of today's function, Professor Debojyoti Bhattacharjee, Senior-most Professor, Chairman of the Local Organizing Committee, Professor Surya Chattopadhyay, Head of the Department of Physics, Secretary of the Local Organizing Committee, and the most important, respected Dr. Syed Arshad Hussain, the convener, PANE 2021, and my humble regards to all the keynote speaker and the invited speakers of different sessions, and the eminent physicists and the teachers of the Northeast University who are going to be felicitated today, to mention Professor Dilip Kumar Chaudhary and Professor Hiralal Dora from Guwahati University, Professor R.C. Tiwari from Mizoram University, Professor T.S. Jakendra Singh from Manipur University, Professor Barin Kumar Dev from Tripura University, Professor B.M. Jairua from Nehu, Professor Tado Carlo from Neris, Professor Imtiwati Jamir from Nagaland Principal Jubilee Memorial College, I, as a president of the Physics Academy of the Northeast Pane for this session, would like to acknowledge the great responsibility of the Department of Physics, Tripura University, for taking up such a crucial decision to organize the 12th Biennial National Conference Pane 2021 at this time of pandemic due to the COVID-19. As mentioned earlier, it was initially scheduled at Tezpur University, but it was not successful. Somehow, I again thank Dr. Said Arsu Hussain, the convener, for prompt action and for agreeing our request to hold this important conference. I was fortunate enough to be present on the first day of the formation of the PANE in a one-day conference on the 100 years of the discovery of electron at the old city office of the IIT Guwahati at Pan Bazar. At that time, I was a young faculty member of Guwahati University. I still remember the discussion by Professor Deka, Professor Pathak, and Professor Anil Goswami, and many stalwarts at Guwahati, Professor Murthy also there. So now it is almost entering 3 decades old, this PANE, a long journey. During this period, I also involved in different capacities of PANE, even once as General Secretary when I was at Guwahati University. During this process, as Kushal Kolita told, Guwahati University has contributed a lot in the historical development of PANE. The PANE journey is very slow and steady, no doubt. PANE had adopted many resolutions in the past and a program from time to time. All of the program we could not exhibit, we could not convert to action. Out of this program, the series of biennial national conference with felicitation of eminent physicists of the Northeast and the award of the young scientists is still a great success, and this will continue for years to come. As mentioned earlier, another success is the publication of a popular, not so technical yearly journal, PANE Bulletin or Journal. It is not a technical journal. No doubt, we have a PANE Foundation lecture on the 6th April every year. Now, PANE, as the General Secretary of the PANE, Professor Kushal Kolita pointed out, that we want to have some new programs in the days to come. PANE is looking for many other new activities in the years to come. Is to mention a few, we want to start a technical journals of physics research. Just like the proceedings of the Physical Academy of Science, we may give a name. It should be a technical research journal. So it should have ISSN number also. So it will give the self-sustaining income also for the PANE, and it will, we will request the UGC to include in the care list also, that we will start very soon. And the PANE should have its own website, dedicated website. Whatever we are having, whatever we have published, it should be a permanent features in the PANE website. So far still, we don't have the PANE website. When it was located at Guwahati, they used a part of the Guwahati University website. When it was at IIT, they used a part of the IIT Guwahati website. That is not a good practice. PANE should have its own dedicated website at any cost, and we should store all the archive in that website. Even though right now, PANE office is located, headquarters located at Guwahati University, sooner or later, we should plan to have its own independent office with a few staff members like peon and other clerical staffs. So just like INSA in Delhi and others, other organizations. So PANE had discussed many times to introduce the recognition of the fellows of the PANE, fellow of the Physics Academy of the Northeast, confined to the Northeast, fellow of the PANE, a respect, a recognition. So that we discussed many times, but now we should introduce in practice, just like INSA fellow, INSA this thing. So like that, we should have the fellow of the PANE. So now one hurdle of the PANE is the fund, money to run the office. So we should request our members, university members, member universities in the Northeast to yearly contribute something, or we should request DST or Northeast Council some seed money to run the office of the PANE. That is a must, and some smart people should help the PANE in this regard. By nature, scientists are not so smart and they don't know how to proceed. Okay, we should take some help in this regard. So as Dr. Kushal Kalita, Professor Kushal Kalita pointed out, PANE should also produce some monograph written by specialists, eminent physicists of the Northeast, and some books. We should earn money. We should level the PANE level on the books. So PANE should have a real platform for research collaboration among the Northeast countries. For example, if there is a specialist in nanotechnology or quantum computing in one university, we should try to collaborate with him through the platform of PANE. So the joint project and the joint collaboration should be the motto of the PANE. Otherwise, we don't have much meaning of the PANE. So someone suggested that the PANE conference proceeding should be published some better journal that Harshad also mentioned. Okay, that was a suggestion given to us, and it will be a image of the PANE also. So Bipin Pal Das, this time Bipin Pal Das not only support money for young scientists, there should be one talk dedicated to Bipin Pal Das Memorial. So I presume that I want to request that the keynote address to be given today should be rechristened as Bipin Pal Das Memorial Talk, so that the Bipin Pal Das family may be happy. So we have many opportunities ahead and many challenges. Almost a 3 decades of existence of PANE is itself a great testimony of its importance and requirement in a Northeastern university. So I declare long live PANE. Thank you all.
Thank you, sir, for sharing your valuable words with us. Now, I humbly request Professor Badal Kumar Datta, Dean, Faculty of Science, Tripura University, to deliver his speech.
Good morning, everybody. Professor Ganga Prasad Pasin, our Honorable Vice Chancellor, Dr. Deepak Sharma, our Honorable Registrar, Professor Devujyoti Bhattacharya, Chairman of this Biennial Conference of Physics Academy of Northeast, that is PANE, Professor Syed Arshad Hossain, local convener of this program, Professor Surya Chattopadhyay, the chairman of this program, the joint convener, Dr. Ratan Das and Dr. Anirban Kuho, and our dignitaries, especially Professor Kushal Kalita, who is the Secretary of PANE, and Professor A. Nimai Singh of Manipur University, the President of PANE, and other dignitaries and eminent scientists, research scholars, or students. After a long time, my relation with the physics up to class 12. After that, this is the first time I came in a seminar or symposium or conference in a physics seminar, especially. And the physics, that is the two stalwart in this world. There is Albert Einstein, the man of relativity, and Max Planck, the quantum mechanics of physics. And in India, Vitali Satyan Bose, Homi Jahangir Bhabha, and our young budding scientists. They are now, we are very proud that physics department continuously, in every time, they are conducting either in symposium or seminar or conference or workshop. And this is the productive department of Tripura University. And they are seriously engaged in research work. This time, when Tripura University is unable to conducting such type of conference, and our Professor Arshad Hussain, Debujyoti, Sucho, they are and other faculty members really accept the offer and conducting this program. That is the PANE. And I hope that this program will be a success. The 3 days will interact with the scientists and our students and research scholars will learn from various aspects, like this program or conference cover all the physics subjects, that is condensed matter physics, material science, atmospheric physics, astrophysics, cosmology, nuclear and high energy physics, communication and instrumentation, so others. So I congratulate the organizers and the physics department, and hope that it will be a success. So thank you.
Thank you, sir, for sharing your valuable words with us. I now request Dr. Deepak Sharma, Registrar, Tripura University, to enrich us with his few words.
Our Honorable Vice Chancellor, Professor Ganga Prasad Prasad, Chairman of the Local Organizing Committee, PANE 2021 Conference, that is 12th Biennial Conference, 3 days conference, Professor Debya Jyoti Bhattacharya, Professor Syed Arshad Hussain, Convener, Local Organizing Committee, Professor Kushal Kalita, General Secretary, Physics Academy of Northeast, that is PANE. Our esteemed speaker from Manipur University, Professor N. Nimai Singh, Dean Sciences, Tripura University, and my dear colleagues, Professor Anirban, I know, lovely students, and around 100 esteemed participants who have joined us virtually. A very good morning and a hearty welcome to this great academic meet. And I also, on behalf of Tripura University, I thank PANE to give us an opportunity to host this significant academic meet in this university. Professor Datta pointed out that he had studied physics till 12th. I have not done even that. So I am completely illiterate in physics. But I know that physics, Professor Nimai said that scientists are not smart, but I certainly understand that physics creates smartness. This smart classroom, the sophisticated gadgets, the virtual media are all the contribution of this great branch of learning called physics. And I also appreciate some of the significant features of this conference. Firstly, it is an open themed conference, giving opportunity to all branches of physics to contribute and giving us an opportunity to interact beyond any kind of boundaries. You know, two things don't have any predefined contours: science and senses. Let us not bind them, let us open them. And this is really a significant step in that direction. Yes, this conference would help us to collaborate, but this collaboration should have clearly defined objectives also. We don't collaborate just to learn, just to take from somebody. We should also, as Tripura University, we should also be clear what we are going to give to PANE and what we are going to give through this collaboration. We can share some of the equipment that we might have, especially in Northeast. We can share some of the expertise, knowledge that this house is creating. Not just in terms of learning, in terms of teaching also. And we should emerge as leader in the Northeast. That should be our objective. This, and with this, I, as you know, from the university point of view, I am delighted to see this pamphlet giving an overview of the academic and research profile of this department of Tripura University. This would certainly help us in the accreditation and assessment process that we would soon be having. I'm also quite enthusiastic about the future initiative this PANE is planning to take. One is, as Professor Nimai Singh just mentioned, about this technical research journal website, dedicated website of PANE, and certain fellowship programs. As a layman, I would also like to make 2 or 3 suggestions. As a research association, our emphasis should be to invest in young minds. So maybe we can have some sort of student internship program or some sort of summer training, you know, for students from Northeast, and maybe we can you know, have this kind of student exchange or faculty exchange programs, because ultimately PANE is dependent on the, you know, the universities and the IITs. Then we can also have, you know, give more emphasis on the hands-on training or the projects, in the sense that we can start some sort of incubation center of PANE, coming from, you know, the scholars, for the scholars and the young minds of the Northeast. So with these words, I would like to end no, my this thing, and I congratulate you and I wish a great success to this seminar and Kane long life. Thank you very much for making me a part of this.
Thank you, sir, for your words.
On the occasion of the 12th Biennial National Conference of Physics Academy of Northeast, held in Department of Physics, Tripura University, members of PANE are honored to felicitate distinguished physicists. I now start with Professor Dilip Kumar Chaudhary, retired professor, Department of Physics, Guwahati University, PANE, and local organizing committee have decided to felicitate Professor Dilip Kumar Chaudhary for his contribution to the development of physics. The area of research interest of Professor Chaudhary was quantum chromodynamics, fractal geometry, and physics of extra dimensions. He published nearly 200 research articles during his research career. 26 research scholars have completed research work under his supervision, leading to PhD degree from Guwahati University. He visited several countries as visiting scientist, namely France, UK, etc. He was also a regular associate of International Center of Theoretical Physics, TRESTE, Italy during 1992 to 1999. He was associated with PANE since its formation and started functioning. Professor Chaudhary was the Vice President of PANE during 1998 to 2000. He was also the Executive President of PANE from 2000 to 2014. During 2008 to 2020, Professor Chaudhary was the President of PANE. PANE wishes his success in his entire future endeavor. On the occasion of 12th Biennial National Conference of Physics Academy, PANE are honored to felicitate distinguished physicist Professor Ramesh Chandra Tiwari, Department of Physics, Mizoram University, for his contribution to the development of physics. Professor Tiwari is the Senior Professor and Head of Department of Physics, Mizoram University. He has 31 years of teaching and research experience, 16 years administrative experience as Dean and Head of Department. He underwent deep training. His research interests are radiation physics, electronics. Under him, 6 PhDs awarded and 8 are registered. He had visited 7 countries, Vienna, Australia, as IA invited expert. He has filed 3 patents, 1 policy document. He got 6 research projects. He has 84 publications, 85 invented talks. He is the member of UGC inspection team, EC of NILET and MZU, NAC co-convener, MZU and AC of Dr. S.H.G. Sagar University and NAC assessor. PANE wishes his success in his entire future endeavor. Next, on the occasion of 12th PANE Conference, the members of PANE are honored to felicitate distinguished physicist Professor Thayam Jitendra Singh, retired professor, Department of Physics, Manipur University, for his contribution to the development of physics. Professor Singh attended a course on the management of University Media Center at the University of Dundee, Scotland. He also worked as Indo-US Senior Fellow at the University of Maryland, USA on Fulbright Fellowship. Professor Singh worked for the establishment of the AVRC, now known as the Educational Multimedia Research Center at the Manipur University. Also, he was the member of Textbook Development Committee for Physics, NCERT, New Delhi. Pane 2010 conference held in Manipur University was organized by him. Professor Singh was also the joint organizer of SERC School of Nonlinear Dynamics at the Manipur University in 2015. He also translated into Manipuri language one book of Landau's What is the Theory of Relativity? He also published several research papers in reputed international journals and guided several PhD scholars. Pane wishes his success in his entire future endeavor. On the occasion of 12th Biennial National Conference, members of Pane are honored to felicitate distinguished physicist Professor Barin Kumar De, retired professor, Department of Physics, Tripura University, for his contribution to the development of physics. Professor De is one of the pioneer members of the Department of Physics, Tripura University. He was attached with the department since the department was established in 1990. He was retired in 2019, but still now he is actively engaged in teaching and research activities in the department. During his long service period as a faculty member of department, he established the Atmospheric Research Laboratory in the department and received research grant of tunes of several crores of rupees from Indian Space Research Organization. He published more than 100 research articles in high impact factor international journals. 10 research scholars have been awarded PhD degree working under his supervision. They are now well established in various fields. Professor Barin Kumar De is also an active member of Pane since the last 20 years. He also engaged in various other scientific organizations. Pane wishes his success in his entire future endeavor. On the occasion of 12th Biennial National Conference of Physics Academy of Northeast, members of Pane are honored to felicitate distinguished physicist Professor Hiralal Dhura, retired professor, Department of Physics, Guwahati University, for his contribution to the development of physics. Professor Hiralal Dhura is an astrophysicist and an astronomy promoter of Northeast India. He retired from the Department of Physics, Guwahati University in 2020. His research area includes nucleosynthesis in stars, general relativity and cosmology, active galaxies and high energy astrophysics. He has published more than 100 research papers in his field of research. Professor Dhura is associated with several organizations devoted to astrophysics research and developments. He was the associated with Inter-University Center of Astronomy and Astrophysics, Pune, up to 2017. Professor Dhura had been an active member of the International Astronomical Union in the divisions of galaxies and high energy astrophysics. He translated Michiso Kaku book Hyperspace into Assamese and published the translation around 2016. Pane wishes success in his entire future endeavor. Next, on the occasion of the 12th Biennial National Conference of Physics Academy of Northeast, members of Pane are honored to felicitate distinguished physicist Professor Bitailda Mary Jairava, Professor, Department of Physics, Northeastern Hill University, Nehu, Meghalaya, for his contribution to the development of physics. The research interest of Professor Jairava is theoretical and experimental nuclear physics. She used various models like optical model parameterization, resonance studies of heavy ions, etc. She published a large number of research articles based on her research work. She worked in ICTP Treste Italy for several years with distinguished nuclear physicists throughout the world. Professor Jairava has research collaboration with various universities and institutes in India, namely VECC Kolkata, BHU Banaras, BARC Mumbai, Bengaluru University, etc. She also has international collaboration with the scientists from Russia, Japan, South Korea, and other countries. She worked in the DAE BRNS project entitled Measurement of High Energy Photon and Neutron Reaction Cross Sections of Structural and Cladding Material related to the medical isotopes. For adult education, Professor Jarva wrote a book in the local language which deals with the weights and measures of for adults. Pane wishes her success in her entire future endeavor. On the occasion of 12th Biennial National Conference of Physics Academy of Northeast, members of Pane are honored to felicitate distinguished physicist Professor Tadu Carlo, Professor, Department of Physics, NERIST, for his contribution to the development of physics. Professor Carlo is the first person from Arunachal Pradesh to do PhD in physics from University of Delhi and became the first professor of physics in Arunachal Pradesh. Guided by scientific temper, he worked for scientific awareness to the locals of any states and particularly for his home state Arunachal Pradesh. For his work on popularizing physics among the common masses, he received many national and international recognition. He has served as consultant of United Nations, Government of India, and Government of Arunachal Pradesh on different assignments. At present, he is the head of the Department of Physics, NERIS. He has many publications in journals such as those published from Elsevier, American Institute of Physics, Spitzer, World Scientific, etc. Pane wishes his success in his entire future endeavor. On the occasion of 12th Biennial National Conference of Physics Academy of Northeast, members of Pane are honored to felicitate distinguished physicist Dr. Intiwati Jamir, Principal, Jubilee Memorial College, Mokokchung, Nagaland, for his contribution to the development of physics in Northeast. Dr. Jamir joined Fazal Ali College, Mokokchung, Nagaland, as a lecturer in 1986 and served 35 years to teach physics. After retirement in 2021, he joined Jubilee Memorial College, Mokokchung, Nagaland as a principal and continues till today. His research interest is in the area of heavy ion collisions. He published several papers and obtained PhD degree in 2000. He also acted as a member of Academic Council of Nagaland University, member BUGS Physics of Nagaland University, member BUGS Physics of Kohima Science College, Autonomous, Nagaland. Pane wishes his success in his entire future endeavor. With this, I congratulate all the distinguished physicists who are facilitated by the Pane and local organizing committee. Thank you.
I now humbly request Professor Ganga Prasad Prasen, Honorable Vice Chancellor, Tripura University, and Chief Guest of today's inaugural program to address the gathering with his precious words.
Can we start? Good morning and namaskar to one and all. Professor Divyajyoti Bhattacharya, Senior Most Professor of Physics and Chairman, Local Organizing Committee, Physics Academy of Northeast 2021. Dr. Deepak Sharma, Registrar, Tripura University. Professor Surya Chattopadhyay, Head Department of Physics, Tripura University. Professor Syed Arshad Hussain, Professor of Physics and Convener, Local Organizing Committee, 12th Biennial National Conference of Physics Academy of Northeast, Pune. Professor N. Nimai Singh, my esteemed colleague from Manipur University and now President, Physics Academy of Northeast. Professor Kushal Kalita, General Secretary, Physics Academy of Northeast and Professor of Physics, Guwahati University. Dr. Anirban Guha, Dr. Ratan Das, Research Scholars of Physics Department, students of various semester of Physics Department and other department who have come here for this program, invitees, ladies and gentlemen. I am very happy to know that the Physics Department of Tripura University is organizing the 12th Biennial National Conference of Physics Academy of Northeast 2021 in the Department of Physics, Tripura University. We all know that in addition to teaching and research, we as teachers, as scholars, as students must take part in such type of academic event from time to time to enrich our knowledge. You know, every discipline has their own association, and in northeastern region, the association of physics or the faculty members, research scholar, and student of physics, they form an association called Physics Academy of Northeast. And from the report which was told by Professor Nimai Singh, Professor Syed Arshad, that every year this association has been organizing annual conference in different northeastern state of India, and research scholar, faculty members, participants of physics and other related disciplines are highly benefited. I know this subject, physics, is the most popular subject among the subject of science. In science, there are subjects like physics, chemistry, mathematics, life science, etc., etc. But out of those many subjects, which I understand from my association in Manipur University, those students who secure highest marks in +2 exam, both by State Board and CBSE, their first preference is offering of physics honors in colleges. If they could not get admission in physics honors, then they go for chemistry honors, mathematics honors, life science honors, like this. And also, this subject is one of the most popular subjects in my state, Manipur. And the Department of Physics is the most strongest department there in Manipur University, and here in Tripura also. Just 2 days before, the Department of Physics was inspected by one external expert who is also Vice Chancellor of one university. And after inspection, after interaction, after seeing their academic credential, their publication, he was very happy to tell me that the Physics Department of Tripura University is one of the best departments in terms of academic output, research, collaboration, project, etc., etc. And I know Professor Divyajyoti Bhattacharya, Professor Surya Chattopadhyay, Professor Syed Arshad Hussain, Anirban Guha, and Dr. Ratan are all, working together. Whenever they come for any work to me, they come in a team and they present their, their things very nicely. And I'm fully convinced that yes, they are doing very good work. I have seen their project. I have seen their research publication in different occasions. So I am very, glad to inform you that this department will certainly have a very good future. And the students who have passed some MSc Physics from this department are well placed in Tripura and outside Tripura also. And I know about CSIR because I was the coordinator of CSIR NET exam for many years, and I used to go to Delhi in their office. They used to tell me that if there is any student who has passed MSc Physics and qualified for CSIR JRF, not NET, JRF, then they are going to appoint for full-term scientists in different laboratories of CSIR, which are located in different parts of India. So for you, if you pass MSc, it's a very good marks, at least with first class and above. And if you qualify the JRF, then job is guaranteed. As per, a version given by those scientists of CSIR who are working in Delhi. So my dear student, you have chosen a very right discipline. Continue to and get a good, output from your study, from your research, and job as a scientist or as a teacher is not a problem for you in future. I congratulate all those 8 PANE awardees who are from different states of Northeast India, whom we have awarded we have felicited for their contribution for development of physics in this part of country. And I know in Guwahati University also, in Manipur also, in Tejpur also, in Neris also, there are very good, renowned scholars of physics who have been producing, who have been writing good paper, and they are, bringing good name and fame of Northeast region to outside Northeast region in this subject of physics particularly. I will not take much time. Last but not the least, I would like to congratulate the Department of Physics for organizing a program of physicists of Northeast India under the banner of Physics Academy of Northeast. And though many of our participants have joined through online, but they will be also equally benefited. One of the advantages of this online education is that we may not be able to come physically, but we can present our paper, we can interact through online mode also. So they will be also awarded certificate, and that certificate which will be awarded to those online participants will also carry equal weightage like those participants who will present through offline in the campus of Tripura University. I believe that the deliberation, the discussion, the outcome of these 3 days events will be very, very fruitful, and this will throw a new light for the development of physics education in this part of country. I thank the department for inviting me as a chief guest and for giving me this type of honors, and I wish that this department will grow in future. Before me, Dr. Deepak Sharma has also mentioned that they publish this type of annual report type. So I like to request all the department of Tripura University also to publish their performance, like number of students admitted, number of research paper published, number of faculty member who have attended seminar conference in Tripura and outside Tripura, even list of the journals where their paper are published, and some other activity, even activity like debate competitions, recitation competition, sports meets, annual pressure meets may be presented in this type of report, and this will ultimately help us in compiling our annual report. And not only this, from this year onwards, now there will be only offline classes. I like to advise all the department, including physics department, to organize at least 2 seminars. We can organize more than 2, but we shall try to organize at least 2 seminars in a year related to our topic, so that our students, our scholars may be benefited by participating, by presenting their papers in this conference. I like to advise our dear students, in any seminar, any conference, come forward, write paper. Don't hesitate to come here and present your view in front of your friends, your teacher. This will help. This will help you. This will develop you. This will bring you confidence of coming over the stage and talking in front of others. Last but not the least, I congratulate and I wish all success of this 3 days academic event. Thank you and bye. Namaskar.
Thank you very much, sir, for sharing your precious words with the gathering. Now, Professor Surya Chattopadhyaya, Head of the Department of Physics, Tripura University, and Secretary, PANE 2021, will deliver the vote of thanks.
Good morning. The Chair, our Honorable Vice Chancellor, Sir, Professor Ganga Prasad Prasad, the patron of PANE 2021 and chief guest of this inaugural session, Dr. Deepak Sharma, Registrar of Tripura University, and special guest of this occasion, Professor Badal Kumar Datta, Dean of Science of Tripura University and guest of honor of this program, Professor N. Nimai Singh, joined in online mode. He is the president of PANE. Dr. Kushal Kolita also joined through online mode. He is the secretary of PANE. Professor Debojyoti Bhattacharjee, chairman of this conference. Professor S.A. Hussain, convener of PANE 2021. Dr. Anirban Guha and Dr. Ratan Das, joint conveners of this program, of this seminar. All the respected members of PANE, all the respected delegates attending the conference, faculty members of other departments, research scholars and PG students of Department of Physics present in this occasion. It is my privilege to have been asked to propose a vote of thanks on this occasion on behalf of Department of Physics. First of all, I express my sincere gratitude to our Honorable Vice Chancellor, Sir, Professor Ganga Prasad Prasad, for his kind presence to this inaugural session, despite of his busy schedule. My sincere thanks to you, sir. I am also grateful to our distinguished guest, Dr. Deepak Sharma, Registrar of Tripura University, Professor N. Nimai Singh, Department of Physics, Manipur University and President of PANE, Professor Kushal Kolita, Secretary of PANE and Professor of Department of Physics, Guwahati University, Professor B.K. Datta, Dean of Science, Tripura University. Despite of their busy schedule, they managed time to remain present in this meeting. My sincere thanks to all of you, sir. I am also very much thankful to the chairman of this conference, Professor Debojyoti Bhattacharjee, convener Professor S.A. Hussain, joint conveners Dr. Anirban Guha and Dr. Ratan Das, joint conveners of PANE 2021, for their constant effort to arrange the program successfully. Thank you, thanks both of you, sir. I am also very much grateful to the delegates for their participation into PANE 2021. I hope that they will be benefited from their interactions with resource persons of different technical sessions. I am also convey my sincere thanks to all the research scholars present here. Actually, they have worked hard to arrange this program successfully. The officers and staffs of this university have helped very much to arrange this program. Many thanks to all of them. Finally, we take the opportunity to thank the sponsors of the conference, especially the Science and Engineering Research Board, DST, Government of India, Bipin Pal Das Trust, Guwahati, Assam, Physics Academy of Northeast, and obviously our Tripura University. Thanks to all from my side.
Thank you, sir, for the vote of thanks. With the permission of Honorable Vice Chancellor, Professor Ganga Prasad Prasad, we are closing the inaugural session of the program. I thank you all for your presence during the inaugural session. I would request all the delegates and participants to join for high tea in front of the seminar hall. And after the tea break, we are entering into the first technical session with a keynote lecture for Professor Sabu Thamas and Vice Chancellor and of Mahatma Gandhi University, India. And I would request all the online and the offline participants to be present at 12 p.m.
Uh, my dear delegates and participants, there is an announcement. Actually, we are a little bit late. It was supposed to start at 12 o'clock, so we should start at 12 o'clock. There was a gap, but we will continue the program. As soon as our keynote speaker, Professor Sabu Thomas, will join with us, we shall start the keynote address. So, the online participants, I request you all to kindly be with us. Okay, thank you very much. So, we shall start soon.
Can you hear me? Very good, very good. Thank you. Thank you. Very good morning to all of you. Very good morning. Thank you, Professor Hussain, for the kind words of introduction. I'm extremely delighted to be with you today, and I would like to share some of my work with you today. And I wish all the best for this exciting conference. Very important topic. Can you all hear me? Dear friends, can you hear me?
Yes, sir.
Can you see my slide?
Yes, sir.
Are the slides moving now?
So,
Not yet, sir.
Oh, then I will check again. Are the slides moving now?
yes, sir.
Okay. So the title of my talk is Circular Economy, New Opportunities in Sustainable Nanomaterials and Green Polymer Bio Nanocomposites. Dear friends, I'm going to show you some of the activities of my group on bio nanomaterials. We extract nanomaterials from agricultural waste, agro waste, and transform them into high performance functional materials. That is the core of my presentation. Those who want to know about my work, you can look at my web page. You can look at my web page, sabuthomas.com. I will now go to my next slide. You can see the ACS statistics. ACS says 1.6 billion tons of agro waste are being accumulated across the globe. And if you look at these agro waste include agricultural waste, waste from the fish industry. As you all know, India has a long coast, so we have a lot of fish waste. And this could be transformed into advanced functional materials. I have mentioned some of the biomass utilization process. My next slide is a variety of agricultural waste, which include sugarcane bagasse, because India has lots of sugar producing companies. Brazil has, China has, and we produce a lot of bagasse. And this bagasse materials are not utilized for any functional applications. Most of the time, they are used as fuels. Wheat bran and rice bran, corn cob, wood flour, wheat and rice straw, variety of agro waste. I have a beautiful table here. In this table, you will find regarding the fiber source, wood is number 1. You can see the world production and the origin, followed by bamboo, cotton, jute, canaf, flax, sisal, and the list continues. There's so much of agro mass being accumulated in the globe, and these agro waste are not being utilized. We utilize only 10%. 90% of the agro waste materials are wasted. Coming to the plant fibers offer lots of advantages: environmentally benign, cost-effective, abundant. There are lots of advantages on plant fibers. Look at some of the plant fibers: softwood, bast, leaves, seed, fruit, variety of plant fibers. And we have, banana, got a lot in Kerala. Coconut, Kerala is the land of coconuts. Pineapple, oil palm industry in Kerala is coming up in a big way. Bamboo, we have jute, but jute is more focused in the northeastern side of India, West Bengal and Bihar. Coconut, plenty of coconut-based industries in Kerala. Let us look at the price of this material. Taking cotton as an index of 100, you will find these materials are relatively cheaper. Straw is the cheapest. It could be straw from rice plant or a wheat plant. Coir is also quite cheap. I wanted to show you the mechanical properties of this material. If you look at the mechanical properties, they're as good as glass once you divide the properties by density, specific properties, because the density of all these fibers, abaca, bagasse, bamboo, look at this value, 1.5, 1.2, 1.1. But if you look at the density of glass, it's much higher, almost double. Therefore, the mechanical properties, specific properties of these materials are better than glass fiber composites. If you look at the chemistry of this material, lignocellulosic material, the essential component is cellulose, very exciting molecule. Lignin, complex hydrocarbon, and you have hemicellulose. And another important characteristics of plant fiber is the hierarchical structure. You can work in different length scales, the macro length scale, the micro length scale, and you see inside the microfiber, you have large number of nanofibers. Dear friend, these nanofibrils are cemented by lignin. And once you remove all this cementing material, you can have nanocellulose. And I wanted to tell you that nanocellulose is the most important strategic platform for sustainable development. Why? Because of its high crystallinity, high mechanics, low density. There are several exciting properties for nanocellulose. How do you make them? You can make them by high pressure homogenization. You can make them by grinding, cryo crushing. There are several techniques which are matured now. If you examine under high resolution electron microscope, nanocellulose looks like a continuous entangled network. And the fiber length could be several micrometers. And fiber diameter could be in the range of 20 to 100 nanometers. And this is actually the nanocellulose gel. If you examine the naked eye, it's taken in a transparent glass. How do you produce them? High pressure homogenization, super grinding technique invented by the Japanese professors Abe and Iwamoto. You can see the exciting paper in biomacromolecules, cryo crushing, ultra high intensity ultrasonication process, steam explosion process. You submit everything into a steam explosion chamber and you increase the temperature to 150 degrees Celsius and the pressure is 137 Pascal. And you keep it for about 10-15 minutes and then suddenly you release the pressure, then you have an explosion taking place. So cellulose is opened up and you have chemical hydrolysis of lignin and hemicellulose and you get the nanocrystal, so nanocellulose. I will show you the totality of the manufacturing step being adopted in my laboratory. We collect the agro waste from the farmers' agriculture farm. We clean them, chop them into smaller length. We do an alkali treatment for removing lignin and hemicellulose. We get a slurry. We go for a acid hydrolysis. It could be strong acid or a weak acid, steam explosion, homogenization. What we get is we get a milky liquid. This is nothing but suspension of suspension of nanoparticles in water. And if you examine this under electron microscope, you see a beautiful entangled network of nanofibers. Dear friends, we can make long nanofibers. If you use mild acid, this is long nanofibers where you have amorphous and crystalline segments coexist. If you use a strong acid, you get away all the amorphous part and you have short nanocrystals. And you see, look at the mechanics. The mechanics are quite high. The modulus is very high. The strength is pretty good. And you can get small nanocrystals or nanofibers. So both ways you can get nanocrystals or nanofibers. And I will show you the process in MGU. We have a raw fiber. The raw fiber is subjected to steam explosion process. And then we have a bleaching process, acid hydrolysis. We very often repeat this process 2-3 times till we get the required dimension. Then we go for centrifuging, and finally we get the nanocellulose. I will show you some of the nice fibrils produced by this technique. You can make beautiful structures. You know, this is the structure made from banana stem by my previous co-worker. He's right now in US for a postdoc, Mr. Eldo Abraham from pineapple, from banana stem. This is from wood flower. My former co-worker right now in Russia made beautiful nanofibers from wood flower. This is a Swedish collaboration. This is what we have done with Brazil, Sao Paulo University. We have extracted nano from pineapple leaf fiber. And another important point I want to tell you, dear friends, we can do exciting chemistry on the surface of nanocellulose. We can do TEMBO-mediated oxidation process. The OH could be converted to COH. You can do esterification reaction. You can do polymer grafting. You can introduce fluorescent labels on the surface of nanocellulose, and you can do exciting fluorescent spectroscopy measurements, either non-radiative or excimer fluorescence. You can do cellulation reaction. We have entered into a contract with Apollo Tires to do cellulation reaction on nanocellulose to use them as reinforcement for tread of tires to replacing carbon black. We are also working on cationization reaction. So several reactions could be performed on the surface of nanocellulose to make it hydrophobic. Now, dear friends, I'm going to show you the important application of nanocellulose. You can use it for water purification. You can use it for the manufacturing of sensors, EMI shielding, wound healing. Let us take water purification first. I'm sure you all will agree with me that water is going to be very scarce material in the coming years. India needs lots of water because we have a big population. So my PhD student and I decided to work on developing advanced functional filters for water purification. So we looked at the commercial filters. If you look at the commercial filter, the bottom part is nothing but non-woven microfiber support. Just above that, you have the electrosponge system. This is the structure of the typical system. And what we did is to make it efficient. We have decided to give a coating of nanocellulose. This is a hydrophilic coating. So we bought the typical filters, and then the filter surface, top surface is coated with nanocellulose to make it more efficient to removal of dyes, nanoparticles, heavy metals, oils, bacteria, and viruses. So, dear friends, look at the company pumping out, wastewater from a textile industry, and it's full of crystal violet dye. The water is actually quite violet in color because of crystal violet. And what we have done is, in order to utilize in order to make the commercial filter more efficient, what we did is we made some chemistry on the surface of nanocellulose. We made nanocellulose, reacted nanocellulose with the meltrum acid. This is a green chemistry route, and we have introduced CO- group on the surface of nanocellulose. Once you do that, Dear friends, what we can do is we can have electrostatic interaction between, this is a crystal violet dye and modified nanocellulose. This is electrostatic interaction. And you see all these dye molecules could be retained on the modified surface of the filter. This is a modified filter. See, this is before filtration, this is after filtration. This is the nanocellulose coating, and you can see all the violet dye particles are being retained by the membrane. And you can see the removal efficiency. This is the commercial filter you get in the market. And this is the filter modified with unmodified nanocellulose. This is a filter modified with a chemically modified nanocellulose. You can see the efficiency of the membrane increase remarkably. Now let me show you, probably we all agree with me that water is increasingly contaminated with suspended particles. It could be iron oxide, could be different types of metal oxide particles or other suspended particles. Solid particles, silicon dioxide particles. So we decided to remove suspended particles using modified membrane. Look at this. See, we have bought the commercial membrane. The surface of the commercial membrane is modified with nanocellulose. No chemistry here, no chemical modification. You can see all the suspended particles in the range of 20 to 100 nanometer and above are all retained by the membrane, because the holes that we have made by coating. Once you coat the commercial filters with the nanocellulose, the hole size in range of 5 to 8 nanometer. So all these bigger particles beyond 10 nanometer are stopped by the membrane. And you can see this is full of suspended particles. And you can see this is our impure water, black in color, no transmittance. Once you do the filtration process, look at this. These water is clean and you have 100% transmittance. I wanted to show you a very interesting work of Finnish group. Finnish group wanted to purify seawater. Probably you all agree with me that seawater is increasingly contaminated by oil coming from the ship. Several ships sink. Oil actually leaks from the ship, and the seawater is increasingly contaminated. So the Finnish group made aerogel out of cellulose. Then they did some interesting thing. They coated the aerogel with titanium dioxide to make the surface hydrophobic. Once you do that, dear friends, you sprinkle all this aerogel in seawater, and from the seawater, contaminated seawater, the oil is getting absorbed by this aerogel because the surface has been made hydrophobic. So like dissolves like. Water cannot penetrate because the surface is hydrophobic. Once the aerogel takes all the oil, you collect it, either you burn it or you crush it, you press it and get the oil back and reuse it. So these are the two processes you can do. Now let me show you another important slide. Dear friends, nanocellulose is a very good filter to remove metals from water. For example, chromium-6 has been removed by Professor Wang and group. You can see they did a small chemistry that is polyvinylamine. When you put polyvinylamine on the react to the polyvinylamine, you can put massive amino groups. When you have amino groups, you have electrostatic interaction between chromium-6 and these positively charged nanocellulose. So you can have electrostatic interaction, you can trap metal ions. Look at this, we can remove not only chromium, you can remove nickel, cadmium, lead. And we have a comparison with the rice straw fibers. Probably you know that our forefathers used to use rice straw fiber for removing, for purifying water. This is again a very good filter, but not as good as nano. Now let me show you another important slide. These nanocellulose could be utilized for removing microbes from water, bacteria and viruses. And we are all affected by the coronavirus. So viruses could be removed using nanocellulose. And you can look at the process. The bacteria are bigger in size, so you can remove by size a solution because the pore size are so small. So bacteria could be retained on the top surface. But if you want to remove viruses, they are very small, And if you want to remove viruses, then you have to do some chemistry. The best chemistry is, as I mentioned earlier, polyvinylamine. You introduce massive amount of amine groups on the surface of nanocellulose. And then the viruses could be trapped, because virus has a protein envelope. It's got a negative charge, and you can have electrostatic interaction between positively charged nanocellulose and negatively charged viruses. So you can remove virus. You can remove bacteria. This is a very interesting slide, dear friends. A gentleman suffering from high degree of burns on his face. His face is covered with nanocellulose. Nanocellulose being porous, the tissue regeneration is quite rapid. And you can also introduce antibiotic, so that sustained release of antibiotic could be facilitated to this membrane. And the next slide is the work of our joint work with Brazil. My Brazilian counterpart, what we have done is, he's a very brilliant scientist, and he has made polyurethane materials, which is very efficient for manufacturing of heart valve. So my collaborator from Brazil made biocompatible polyurethane for the manufacture of heart valve, and he visited my campus, and he was fascinated by our work on nanocellulose. Then we decided to collaborate, and we sent our nanocellulose to Brazil and see what sort of property improvement you got. The neat polyurethane, the strength is 17.5. By adding 5% of nanocellulose, the strength becomes 52.6. Look at the E modulus. E modulus has a quantum jump, 992.4. And dear friends, then we got a very big Brazilian collaboration. Several of my students went to Brazil, and my Brazilian counterpart is a brilliant chemist, and he had a cooperation with the Brazilian hospital. And you know, dear friends, what we have made? We have made nanocellulose, polyurethane, prosthetic heart valve. That was a joint work with the Brazilian hospital. And we also published subsequently, and we have a series of patents on this. Now let me show you another important aspect of nanocellulose. We can use it for my good friend from Spain. You know what he did? He made nanocellulose aerogel. He made nanocellulose aerogel, and then he introduced antibiotic into it. And you can see the sustained release of antibiotic from nanocellulose platform, very much biocompatible. Let me show you our work of Professor Liu from China. Professor Liu has made nanocellulose collagen aerogel. And you see this aerogel is extremely porous. Porosity is very close to 95%. And water holding capacity of nanocellulose collagen is 4,000%. And Professor Liu, demonstrated this as a very interesting biocompatible material for wound dressing. It is able to absorb all the pus, all the water from the wound. And you can also introduce antibiotic for the sustained release of medicine. Now let me show you another important slide. This is again from a Chinese group. Typical filters that you get in the market, they are all actually they all have weak mechanics, because they are all made by electrospinning process. Look at the polyacrylonitrile membrane, weak mechanics. But if you coat one side with nanocellulose, the mechanical properties become 10 megapascals. And if you coat both sides, it become something like 14 megapascals. So the strength could be increased by coating with nanocellulose. Let me show you what we have done during the COVID time. We had a very active cooperation with many laboratories. Many labs are involved. This is a cooperation with Georgia Tech in the US and several labs in India, including a university in Assam. So we decided to make a new mask, a tri-layer mask. The outer layer is proposed to be made of polyester coated with a polyelectrolyte, which is anti-adhesive, hydrophobic. And the middle layer is proposed to be made by electrospinning process, engraved with positively charged nanocellulose and curcumin. And the innermost layer, which is in close contact with your mouth, is made of nylon. And you see when the coronavirus approaching you, you see this outer layer is anti-adhesive, hydrophobic. It can repel coronavirus. And if at all coronavirus gets into in your mask, if you are careless in wearing the mask, viruses could get in. The middle layer has been engineered such a way that it is called positively charged nanocellulose. It can kill the coronavirus by electrostatic interaction. Additionally, we also coated with curcumin, is an antiviral, and the innermost layer is very comfortable coating. And this is our mask design electrosponge system. There's the innermost layer, there's a middle layer, and there's the outer layer. And we also proposed that this could be made by 3D printing, 3D printed respirator mask. Now let me show you, this is a nanocellulose is a very interesting material for EMI shielding applications. So several of my students have worked on EMI shielding. Currently we have quite a good number of students working on EMI shielding, and I'm going to some interesting results. This is actually a very interesting work of Chinese group. What they did is they mixed nanocellulose and CND together, then mixed with rubber latex. Went for coagulation, hot pressing, they made 3D hierarchical conductive network. Very simple configuration. And dear friends, you might be surprised to see this result. If you put CND alone in natural rubber, you'd always get a percolation. And this percolation is around 6.5 volume percent of CND if you mix CND and natural rubber latex together. But if you mix CND and nanocellulose together, put into natural rubber latex, you see the percolation process, percolation shifted to lower concentration of CND, something like 1.5 volume percent of CND, you have percolation. And dear friend, this is a very exciting strain sensor. When you touch it, the percolation would be broken and it could be a very good strain sensor. And the Chinese colleague has made exciting sensors. Similarly, dear friends, we can combine reduced graphene oxide and nanocellulose together, put into natural rubber latex. Solution mixing technique, latter stage compounding, you make a composite. If you put reduced graphene oxide alone, you have percolation process, and that percolation is very close to 0.75 volume fraction of graphene oxide. But the percolation could be reduced to lower concentration. You see, if you have RGO and nanocellulose together. So dear friends, hybrid structures are very fascinating material. When you hybridize nanocellulose with reduced graphene oxide or CND, you get excellent dispersion of CND and reduced graphene oxide. You can reduce the percolation threshold. That can act as an excellent strain sensor. I don't want to go much details into it. Let me show you another interesting slide of Professor Wang from China. Professor Wang made nanocellulose aerogel, and then he went for pyrolysis. When he went for a pyrolysis, you know what he got? He got carbon aerogel. And this is what is shown over here, carbon aerogel. He went for pyrolysis. And this carbon aerogel is extremely porous. And then Professor Wang demonstrated this material as an excellent anode material for lithium-ion batteries. Since it's extremely porous, the electrolyte ion interaction is very strong. So he got very good efficiency. Let me now show you a very interesting work from my group. My former PhD student, Gopakumar, made nanocellulose dispersion. Then he introduced aniline. Then he has polymerized aniline on the surface of nanocellulose. And you see, after polymerization, he got a beautiful paper, which is very flexible. You can see very lightweight paper. And this paper is a good EMI shielder. You see the total manufacturing protocol, very simple. This is the nanocellulose dispersion in water, injected aniline. He went for vacuum filtration, hot pressing, and you see he made very flexible nanocellulose paper. And this paper is a very exciting material for electromagnetic interference shielding. You can see this is extremely conductive. And Deepu could achieve something like 25 EMI shielding value. And we are able to make papers of different thicknesses, 0.5, 1.5, 0.3 mm. Now let me show you another interesting part of the work. We are also into waste from fish industry, particularly crab shell and prawn shell. And if you look at this material, this is nothing but chitin. This is the structure of chitin, very similar to cellulose, but you have an exciting NHCO-CH3 group. This functional group does a lot of exciting, job. And dear friends, we can make nanochitin crystals, shock crystals. You can also make nanochitin fibers. Very simple. You do an acid washing. You remove all the protein by washing. And I wanted to show you one work because the lack of time. Look at this is nanocrystal of chitin made by acid washing. This is hydrophilic. And you can do a small chemistry by reacting with the bromohexadecane. If you react with the bromohexadecane, in hydroxyl groups, you can put alkyl group on the surface. And dear friends, you can control the number of alkyl group. By controlling the number of alkyl group, you can control the hydrophobicity. Look at the next slide. As you increase the number of alkyl group on the surface of nanochitin, the chitin surface becomes increasingly hydrophobic. And one can reach 158.2 contact angle. That means you can make super hydrophobic chitin by introducing alkyl group on the surface. And this is a very exciting material for structuring the viscosity of oil, especially hydrophobic oil, controlling the viscosity of oil. And you can see the agglomeration of the nanocrystals. Another exciting work I wanted to show you is my former PhD student went to Slovenia. We had a very active collaboration, and my Slovenian counterpart was interested to remove indigo carmine dye from water. So some of the companies in Slovenia, the rivers were contaminated with indigo carmine dye. So he was interested to remove this dye. So conventionally, they were using PVDF membrane. If you use PVDF membrane, the removal efficiency of this dye is something like 25% or 22%. But we decided, you know what we decided? We decided to have a hybrid construction, hybridizing nanochitin and PVDF together. So we introduced nanochitin to PVDF and then went for electrospinning. When you do the hybrid construction, you can see the removal efficiency became 88%. A quantum jump in removal efficiency. So this could be an excellent filter for removal of dyes. I'm going to the last part of my presentation. Maybe within 2 minutes I will finish. We are into starch, waste potato, waste rice, waste wheat, waste sorghum, waste tapioca, cassava. We have a lot of cassava in Kerala. So what we do is we collect the waste. We don't touch the food sector. We collect only the waste. We do an acid washing, and you know what we get? We get nanocrystals. Thanks to Alan Dufresne, he was the first scientist who demonstrated that one can make beautiful nanocrystals from starch by acid washing, and you can control the acid concentration, duration of the treatment, agitation, acid type. You can control the size of these nanoparticles. Here, friends, I wanted to show you my last slide. This is a very exciting work of my PhD student. My PhD student introduced nanocrystals of starch into natural rubber latex. And you can see how the properties went up. This is neat natural rubber. Natural rubber is transformed into a high modulus material by introducing nanocrystals of starch. You can see the nanocrystals of starch formed a network inside natural rubber. And natural rubber became sort of immobilized. That is why you get a very high modulus. Dear friends, I'm making my conclusion. Agro waste are very exciting material. So please don't throw away the waste. Waste are very valuable materials. We can make advanced functional materials from waste. The concept is waste to wealth. And lignocellulosic materials, we can make wonderful reinforcing filler. We can transform them into water purification filters, very good material for wound healing, energy storage, EMI shielding. And the seafood industry, we can get a lot of nice chitin from this nice chitin. We can make nanochitin whiskers or nanochitin fibers. Excellent material for soil remediation, water remediation, wound healing, large number of applications. Similarly, the starch that we get from as waste from agricultural land could be transformed into nanocrystals of starch and exciting material for reinforcement. So dear friends, my question to all of you is, can we become a zero waste planet? So my answer is yes. We have to intelligently transform all our waste into advanced functional materials. And I would like to thank all my co-workers. They did exciting work. And I have Anandu and Suji. They are, sitting in my room. They are also developing new exciting EMI Shield Days. I have many good collaborators. Thanks to Professor Sienna Rao for supporting the laboratory of mine with the through nanomission project. ISRO is acknowledged, CSIR, DBT, AICT, UGC, DRDO, my international funding from France, Sweden, Slovenia, Chuas, Brazil, DuPont Company, General Cables, Surface Street, MRF and Apollo Tires, and my collaborators from worldwide, from Brazil, from France, from South Africa, from Slovenia. And this is my group in chemistry, my group in nanoscience, and I'm the editor of Nanostructures and Nano Objects. So those who work on nano, please submit your article to this journal. This is not open access. This is a traditional Elsevier journal, no fee. After the COVID, please visit me in Kerala. It's a very exciting part of India. Some pictures of, you can have houseboat. And this is our campus. I'm sitting in this building now. This is our entrance of the university. This is chemistry, nanoscience. And I'm organizing a conference this week, international online conference on holistic approach to immunity to microbial diseases. So we have this is particularly on COVID. So those who are interested can join this conference on Friday, Saturday, and Sunday this week. And thank you so much for your patient hearing. Thanks a lot. Any questions, please? Dear friends, can you hear me? I cannot hear you. You are muted. Any questions, please?
Yes.
Can you hear me?
Yes, sir. Yes, sir.
Dr. Hussain, can you hear me? Yes, yes. Can you hear my lecture well?
Yes.
Any questions?
If you have any doubt, you can raise
Arshad, this is Dr. Ashwin Chauhan here. I'm online.
Do you have any questions?
Thank you so Professor Thomas, thank you so much for interesting and it's like a wonderful talk and so much to learn. And so my question here is, since I'm a biologist working in microbiology field, and I see a lot of collaboration opportunity here. So we work on infections, and we are also one of the contributors in the book that we're editing on nano. So my interest here is on nanocellulose, that how we can integrate these nanocellulose on devices, medical devices. You talked about wounds, but we are interested in medical devices like catheters, urinary catheters, central venous catheters, because it looks like a very interesting molecule to be grafted on these. And if we can we would look forward to the collaboration because we are looking forward for collaborations in chemistry and physics because we are not part of it. So yes, so this is what I wanted to communicate.
So this is a very interesting part. You can use nanocellulose as a reinforcing material in catheters. Many catheters could be reinforced by nanocellulose. And nanocellulose is a biocompatible material. And nanocellulose, you can also do electrospinning. Okay, there are various ways you can make use of nanocellulose in biomedical applications, as a scaffolding material. So if you have a polymeric matrix, you can use nanocellulose as a reinforcement. Catheters, you can make silicon rubber. Silicon rubber could be reinforced by nanocellulose, but you have to do some surface chemistry because silicon rubber is a non-polar material, nanocellulose is polar, so you can do cellulation reaction. So several such chemistries could be done, and you can utilize nanocellulose as a reinforcing pillar in all catheters.
So how can we reach to you, Professor Thomas, in order to extend the collaborations?
You can send your overcase here. Now, after Corona, please send them here. You can utilize my facilities here, and we can sign an MOU, and some of the faculty members can come to my laboratory, and we can work together.
Perfect. Thank you so much. Thank you so much. This is what
Absolutely. We can have joint PhD program.
Absolutely.
Several ways we can collaborate. My lab is open to all of you. And I'm very
Thank you
pleased
so
to
much.
support you. Yeah.
Thank you so much. Yeah.
Several ways we can cooperate. Any more questions? If you have more questions, dear colleagues, you can send your questions by email. I'll be very pleased to answer. And if anybody is interested to collaborate, please send a mail. I'll be very happy to support you.
Sure, sir. So I would request the participants to write, sir, if any query or collaboration, whatever may be, directly by email. We are a little bit late with the schedule. So let's thank you, Professor Thomas, for kindly accepting our invitations and be with us. Thank you, sir.
Thank you.
And near future
Thank
also,
you so much. Thank you.
we expect we will
You're all
have your
welcome.
support and cooperation and guidance also. Thank you very much, sir.
Thank you so much. Bye-bye. Bye-bye.
So, dear participants, now we are moving towards the first poster sessions. And I have already told you, I have uploaded all the posters in the websites. You might have gone through them. Now, this session will be chaired by Professor Ramesh Chandra Tiwari from Department of Physics, Mizoram University. And poster number 2 CMPS, 248 CMPS will attend these sessions along with the other participants. And any participants, if you have any query regarding these posters, you can put your query or question in the chat box. Chairman sir will read out and concerned with the number, and concerned presenter will clarify the doubt or query. So I request sir, Professor R.C. Tiwari sir, to take over the charge of the session, sir. Please. Tiwari sir, are you here? Tiwari sir?
He is not here, I think.
No, I talked with him by phone few minutes back, and he told he is
He
already
was
online.
here. A minute ago he was here.
Anyway, the sir will join with us. So if you have anyone has any query regarding these posters from 2 CMPS to 48 CMPS, put your query in the chat box. Yes, yes. Okay, I am coming there.
Yeah, Professor Arsad, probably that two CMPS he can start. That in the meantime that Professor Turi will join. Okay. Yeah, that. Yeah. That, but you have to run that PPT file or that video. Okay, fine, fine. Okay. It means that the not the presenter but that the participants should ask question. But now that participants they should see the video first of all, not now, beforehand. Or maybe quickly if, that one video can run quickly, say. Not all, maybe one or two video can be run probably. Yeah. This, yep. This is structural, optical, and antibacterial properties of CDS nanoparticles. Adding preparation, nanoparticles preparation. Edible oyster mushroom extract, a green synthesis approach. This is Dr. U.S. Sanapati, Department of Physics, Handy Girls College. They have done XRD, TAME, UV visible, FTIR. Yeah. Yeah, I have put one questions. Yeah, the first one. This is first one, 2 CMPS. It is given in the set box. Yeah. Yeah.
Yes, sir.
Yeah.
Hello. Yeah, there are different uses like you can use in solar cells and semiconductor lasers, and we can use in switching, optical switching. There are many application in nonlinear optics. These are the application we can use using CDS nanomaterials.
So have you done some device in your laboratory?
No, I have not prepared any laboratory, but there's prospect of these nanomaterials for optoelectronics device from different characteristics like UV visible spectrum. We get band gap up to 2.98 electron volts, which is much higher than its bulk counterpart, 2.442 electron volts. So there is prospect of getting different optoelectronic devices using these synthesized materials.
Okay, thank you.
Yes, sir, I'm present, sir. Yes, sir. Yes, sir. Okay, sir. The objective is that in ionic liquid, we vary the size distribution, or we pick the sizes of the ionic liquid from a distribution in order to, make a mixture of ionic liquids. So we study the effect of these mixtures in the how it affects the static properties of the ionic liquid, such as or structural, spatial distribution, yeah, and some hysteresis behavior. Yes, sir. Okay, sir. Yes, sir. Okay, so thermal energy storage, we can apply these results to thermal energy storage. Okay, so in my presentation, I have shown I have traced the hysteresis loop for the heating cooling curve, and the loop area. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. So from this study, I have found that by varying the size distribution, there is variation in the hysteresis loop area. So this study gives us the possibility to fine-tune the thermal hysteresis of the system.
Yes, sir. I'm present, sir. Yes. Yes. Yes, sir. Actually, we have not. What question he asked is we have not directly annealed zinc oxide for preparation. After it was sputter deposited on porous silicon substrate, we had annealed that zinc oxide deposited porous silicon substrate for optical application purposes, so that we can enhance or what we get as if we get better performance in photosensing applications or not, that we had studied. But for zinc oxide preparation, we had or zinc oxide deposition, we had directly used the pulse DC magnetron sputtering process. We had not annealed that one. After preparation of zinc oxide on porous silicon substrate, we had annealed that whole heterostructure. Yes, sir. No, no, sir. Yes, sir. Yes. Yes. Yes.
Sir, I have a question, sir. I have a question for 18 CMPS, Mr. Boda.
So 18 MPS, you are present? Mr. Boda, are you present?
Sir. Pardon me, sir. Yes. What is the question, sir?
Yes, so I have a question. In your work, you have shown that the structural change is done in some certain temperature. At 533 Kelvin, the structure change of your material, what you have chosen. So, have you seen any kind of change in pressure change? Due to pressure, have you found out any changes over there?
Oh, no, sir. We have not done pressure variation.
Okay, so all your study was then for temperature only, or
Yes, sir. Yes, sir.
other you have done?
Pardon me, sir.
So actually, I think some pressure also have done some kind of structural. It takes part in this structural thing. So in the next future, you please do study.
Yes, sir. Yes, sir. Sure.
Okay, thank you. I'm done, sir.
Yes, I'm present. Okay. So, zinc-based materials is quite useful in the applications of these absorptions because zinc-based materials is not harmful to the environment. This is the first point. Then another thing is that this zinc-based metal organic framework, when we use for the adsorption for dyes, this zinc 2+, that is zinc cations, can react with the anionic dyes. There is a possibility and high chances of the reaction between them, that is the reaction, the adsorption that is on the on our catalyst. So we use the zinc-based metal organic frameworks.
No, we have not doing these studies.
Sir, can I ask my question directly, sir? I'm Angelin Sharmila. Sir, this is regarding 2C MPS. Sir, then what is the purpose of that antibacterial study that you have done, sir, without any docking studies?
I'm not hearing your question. Can you repeat?
Sir, you have done antibacterial study, isn't it, sir?
Yeah.
Antibacterial activity of your compound. So without docking study, what is the purpose of doing the antibacterial activity? What do you want to show?
So we have seen on using one E. coli bacteria and one standard antibiotic gentamicins, then our synthesized materials has more antibacterial effects compared to the gentamicins. This study shows that our synthesized ZNS can be used for the disease treatments caused by E. coli. So this
Yes,
was
sir.
study.
This is in vitro studies you are talking about. I'm asking about any in vivo studies regarding the antibacterial.
No.
Okay, sir. Thank you, sir. Because docking studies will help you to make it into
Yeah,
a
but
drug.
so we have the limitation of facilities of the biological application, but further
Yes.
we are trying to apply in different
Okay,
purpose.
sir. Thank you, sir.
Yes. Yes, sir. Yes, sir. Uh, Actually, in this work, I have synthesized different concentrations of the European dop, these phosphate nanoparticles, at attaining 5% European concentration. The here luminescent intensity is high because here on attaining this concentration, the host that is YPO4 YPO4 compound, uh, the yttrium site is actually substituted by the this European 3 plus. Here it gets chemically stable state. That's why there is a high luminescent intensity.
Sir, I have one more question. So this is regarding poster 5 CMPS. 5 CMPS Mamta.
Yes.
It is mentioned synthesis, characterization, and application. Ma'am, can you tell me what is the procedure? What is the synthesis procedure that you have adopted for synthesizing your compound?
Yes, I have done the synthesis process by solid state reaction route, and then by thermal vapor deposition method, I deposited the thin films.
Okay, ma'am. Thank you. I was not able to see your presentation. That's why I asked. Thank you.
Actually, there was some network issues. I was not there at that time.
Okay, ma'am. What are the characterizations that you have adopted? What are the
UV visible, XRD, and Raman.
XRD?
Yes, ma'am.
XRD is single crystal or powder method, ma'am?
Powder method.
Powder method. Okay. And then what is the basic application of your synthesized product, ma'am?
Actually, my material was antimony selenide. That is a semiconductor material having optimal band gap and high absorption coefficient. I use this material in solar cell, and currently I'm also working on numerical as well as experimental part of solar cell based on this material.
Okay, ma'am. Thank you. Did you compare with the present currently available solar cells material that is
Yes.
in market?
Experimentally, antimony selenide efficiency is around 9 to 10%, and my paper, I have published 4 papers on this material, and I achieved 24 to 27% efficiency of this material.
Okay.
Actually, it is based on the deposition method or some other techniques. Defect also affect the performance of a solar cell.
Okay, okay. Thank you, ma'am.
Thank you so much.
Yes, sir. Yes, sir. Yes, sir. Okay, sir. UV visible. Sir, here we have shown the most absorption of the tungsten tungsten trioxide dihydrate using 2-markup-to-ethanol. Ethanol at 350 around, and the most absorption is found for the sample which is prepared using the hydrogen peroxide, and using this we plot the tau plot, and after that we got the variation of the band gap as 2.4 for the peroxide, and 2.6 for the markup to ethanol. And there also we show that the crystallite size all crystallite size of the sample prepared using the markup to ethanol is smaller, and band gap also, and so that band gap is higher. Hello, sir. Spectrum. Sir, hello. Okay, sir.
Let's move to the next one. We have another question for 29 CMPS.
Okay.
This is Anju Chanu, Manipur University. Are you present? Anju Chanu, are you present?
Yes, sir. Present, sir.
So I see one question. What is the advantage of hydrothermal method?
Sir, using this method, we can tune the morphology of the samples. So by varying the temperatures during the synthesis process, sir. Morphology. Yes, sir, we can tune, sir. Sir, we can synthesize the without using much temperature, sir. At low temperature, sir. Yes, sir. Yes, sir. It's me. Sir, here in the process, we do not use any substrate. It is in the powder form, sir. We synthesize the composite by the hydrothermal method, sir. We do not use any substrate. It is in the form of powder.
So can you suggest applications of your material?
Sir, many reviews have been done that, and in here also in my work also I have used this samples for the photocatalytic application, sir. A powder form is okay, sir. Grain size. Control so we can just vary this grain size by varying different parameters like this molarity, then temperature, then time of reaction, etc., sir.
Yes, sir. Because it is easy to prepare. Because PVA is easy for the flexible electronic devices, but aniline and ethanol cannot. So, synthesize polyvinyl alcohol. No, sir, it is synthetic polymer. Yes, sir. Because I have seen using polyvinyl alcohol for the flexible by characterizing the sample, and it can be used for flexible electronic devices, but aniline and ethanol cannot be used there.
Excuse me, sir. Sir, my name is Pradyut Rajkumar. I asked a question to 29 CMPS regarding the crystal growth theories involved. So what I asked, what are the possible crystal growth theories for the growth of this copper oxide layer? Like there is a LSW theory, Oswald ripening theory, all these theories are there. If she could suggest some. It's okay, sir. Maybe there is some network issue.
Yes, sir. Sir, I have used pani because pani is a conducting polymer, and it can be easily polymerized by from aniline, and it is non-toxic. That's why, sir.
Yes, sir. Yes, sir.
Yes, sir.
Yes, copper oxide is a very thin material and its band gap can be adjusted with various process parameters. Here I have depicted DC magnetron sputtering using magnetron sputtering technique, and its band gap can be adjusted. It can show direct as well as indirect band gap depending on process pattern. And from the absorption spectra, you can see that it highly absorbs light from 280 to 400 nanometer, and also the absorption capacity of the deposited nanomaterials can be adjusted in the visible region with pressure, sputtering pressure, and deposition time also. And also, as it generally shows theta conductivity, it can be integrated with other semiconductors and also metal particles for different electronic devices.
Yes, sir. I'm present, sir. Okay. Okay, Amlan Jyoti, thank you for the question. Like I have shown only for the magnetite, and I have shown like as I have reported in the results, like with cobalt doping from the XRD, I have got like the crystallite size decreases, and like in the Taos plot also for with increased cobalt doping, the band gap decreases, and like to consider your like what would be its use, like for optical system, like as mentioned in earlier talks, this can be used for like optical device and all, but to highlight you my work, it's mainly focused on the ferrofluid, so I have not done much on these optical properties. Like hello Amnan Jyoti, are you there?
Yes, I am hearing you.
Oh, okay. So I just want to highlight you that I have just taken the Taos plot, and like for with increasing cobalt, here I have choose 0.2 and 0.4. The crystallite size decreases, and consequently the band gap also decreases. That I have not included here, and it's used like for optical device. I have not gone to that level, because right now for this ferrofluid I'm focusing on its flow properties that I have mentioned included at the end of the talk regarding like its rheological properties. Right now I'm focusing on it, and for optical device that will be the future application that I will be interested to work on.
Thank you for your answer. Thank you.
Okay, thank you for the question.
Sir, Shantika Chand, lock and move. So Shantika, you have a question. She has a question from Shuari Jabulma. Yeah. So Shantika, you have a question. What are the few physical properties in which zinc and mercury composition dependence?
Actually, there are several physical properties like structural properties, electronic, optical, where zinc and mercury composition dependence dependence parameters and characteristics are shown. In my slides, I have presented the graph. You see.
So I think you are done. Thank you.
Now,